you need to look at person A, person B, person C. They did something wrong in their work. You have to find what they did wrong for each person, as well as get the correct answer. So 4 things really. Find what each person did wrong and get the correct answer. You can do this on your desk, you can work together, you can use your calculator, Desmos, whatever. I'll give you 5 to 8-ish minutes to work through that, and then we'll come back and we'll talk about it. Does anyone want to circle, underline where person A went wrong? Sure. Circle it, underline it, sure. We'll draw an arrow to where that ended up. Okay. So here, what's wrong about this? Not -6. So I think they multiply by -2 or by 2 instead of squaring it. Anyone find the mistake in person B's work? Okay. And what's wrong with this one?
Like it is minus.
That one. Yeah, so here, this should have been a positive, correct, but then this minus should still be here. Right, and then person C, go ahead. And what's wrong with this one? It should be a positive, right? And then who wants to show the correct work and answer? Everyone wants to do that one. All right, so we should have put these in originally. I'll write this up here. 2 times -3 squared plus 4 times 2 minus the absolute value of 3 times -3. Then we can start doing our grouping. We can actually do this and this 10 times. So 2 times +9. I'm gonna also multiply this part minus this would be -9. And then we're gonna multiply this part and make this positive at the same time. This would be 18 plus 8 minus 9. 26 minus 9. What did that last one? Should have been our final question about. So a lot of these same mistakes were made on your evaluating tests. Maybe not by you specifically, maybe not by someone in this room, but a lot of these similar mistakes were made. So just be careful, pay attention to those things. Today, as you may see on your course calendar, we are starting our next unit on solving equations. Some of this will be review, some of this will be new. Did want to point out a couple things on your course calendar. Not this one. All right. Double check your Delta Math dates. You will have 2 Delta Math assignments due this Friday on what we do today, and then what we do on Thursday will be due next week, because we'll be finishing it next week, and so on and so forth. Double check your quiz date, your test date, and your flex day date, which are also on the board over here, and that's very fun. If at any point, especially after we finish our lesson today, you feel like I don't know what we just did, I need help, please talk to me after school today. Do not wait until the quiz or the test to realize you don't know what you're doing. right? All right, so with our solving, yours says unit 3, ignore that, it should be really unit 2. Anyway, if I asked you, what is a solution, what would you tell me?
An answer to a problem. An answer to a problem.
Answer for problems. So when we're looking for the solution, usually we're looking for the answer to whatever problem we're solving. Okay, now we have to figure out or determine whether the following values are solutions or not. So let's say I solved this equation and I got this as the answer. How would I double check that this is the actual solution for this equation?
Or if bond.
We have to like what we're doing when we're evaluating, putting in a number when x equals 5, putting it back in and simplifying, but now we're doing that same thing, but seeing does this work. We're gonna put 5 in for x. We're gonna use parentheses, so no longer are we using dots, we should use parentheses. And then we're going to simplify this to see if both sides equal each other. If they do, it works. If they don't, then it doesn't. Okay, so 13 times 5 will give us what? Say this out loud. 5. And if we subtract 7, we get. We can say this is a true statement. Whatever we put in equals the same thing on the other side. This is the solution to this problem. This is a good way to check yourself as you're solving problems. Put it back in, see, did you get the same thing or did you get something different? Now, number 2 should not work because we just figured out that 5 was the solution, so we're gonna test it anyway. The same thing. Put -5 in for x. We know this would be -65. We subtract 7, this would give us -72. Which does not equal 58, so this is not a true solution, this could not be the answer to this problem. Okay. I'm gonna show you how you can do this process on the calculator, but also I'm gonna mention this first. So I may have mentioned this before, I know. Because you are in advance, some of your objectives when we quiz or test would be non-calculator. Some of the solving multi-step equations will be non-calculator on your quiz and your test. When we get into word problems, I don't remember if that's calculator or no calculator, I have to double check. So you should get in the habit of trying to do this without your calculator. On a test case, this is a section without it. But you have it to practice with in class as well. Keep that in mind. So in your calculator, everyone do this with me. We're gonna do the first and the second example in the calculator to see how it shows you if this works or does not work. So I'm gonna type in the first example, 13 times 5, so I'm gonna use my parentheses, -7. Then I want the equals. So to get the equals, we're gonna go into test, which is blue above math, so second math. And you'll see there's an equal button. So 1 or enter. And it was supposed to equal 15. And then hit enter. The calculator is going to give you, it's like a true false type thing. It's gonna give you a 1 or a 0. 1, you did this right. 0, you did this wrong, but it's not gonna tell you where is wrong. You'll just have to resolve it, refix it. We're gonna do the same thing we put in -5. Second math is how we get the equals. And you'll see that 0. So now, if I was doing this back to back like this, I could see, oh, it was the negative, that was where I went wrong. But if I was just putting this in out of the blue and I got a 0, I'd have to refix it to see where did I go wrong. But that's a good way to check yourself also, without just putting it back in. Questions on how to check yourself in the calculator? I'm gonna give you a couple minutes. I want you to do the same thing we just did with 3 and 4. Check to see, are these solutions or are they not? Okay. For number 3. I have to make sure this is still recording. Yes, okay, great. For number 3, was this a solution or was this not a solution? No.
Yes.
No, it wasn't.
Not the question.
Okay. And then number 4, was that a solution or was that not a solution?
Yeah, it was.
You need to see either of these on here. Alright, let's move on to the next statement. On this page, these problems are solved for us already. We are trying to figure out what did they do from step to step, using these different properties. So your properties of equality is what you do to one side, you have to do to the other. For addition, subtraction, multiplication, and division, except for distributive, that's really just simplifying to make it more simplified. Okay, so the first step will always be given. That's your original equation. We're looking at what did they do from step 1 to step 2? What changed? What's different? They distributed, then multiplied. So that would be our distributive property. So in this case, when you look to see what did they do, what changed, you see that the 18 is gone, and now this is a positive, so they would have had to add 18, and we'll talk about why here in a moment. So this would be your addition, property of equality. I'm just going to put that. I don't have to make right all of those words. And then from step 3 to step 4. So division, property of equality. Or divided. Then do another one and then I'll have you do one on your own. So step 1 is your given. What happened? What changed in step 1 and step 2? So it was addition, but did they add over here? Fraction, property of equality. And then step 3. Multiply. So they were already dividing, so to get rid of the -3, then you multiply on both sides. So I want you to try example 3, see if you can figure out what did they do from step 1 to step 2 and so on and so forth. I'll give you a minute to do that.
What's that? Really? No, you act like mad.
That's great.
Alright, double check your answers with mine.
I got all of those besides 3.
Okay, so change it, fix it. Do we have questions about any of these? Now that we know how the properties are supposed to be applied, now we can actually apply them and solve. We go on to the next page. Okay, now, I'm gonna ask this question, it's kind of like that question we asked at the beginning, but a little different. Now, if I ask you, what does it mean to solve an equation? What would you tell me? John, what would you say? Find the solution, okay. We are finding the solution by using our properties of equality or our inverse operation. So I'm gonna try it again. To find the solution for the answer by using inverse operations. And then just to make sure we're all on the same page as to what these inverse operations are. If I said, what is the opposite or inverse of addition?
Subtraction.
What is the opposite or inverse of division?
Multiplication.
The opposite of squaring something.
Cube. Square root.
Square root. So these undo each other. So if I
That
had
is
like
crazy.
2 squared is 4. The square root of 4 is they undo each other. So then cube and cube root also undo each other for our inverse operations. 2 cubed is 8. The cube root of 8 is 2. So they undo each other. Right, take a second and read through these. These are your baseline, if you don't know where to start, and you can do any of these, right? If you can distribute, if you have parentheses, do that. If you don't, we're not just distributing just because. If you have like terms on the same side, combine them. If not, don't do that. Move the constant by adding or subtracting to the other side, and then get the variable alone by multiplying or dividing. So I want you to look at these problems. Look and see which ones look complex, you're not sure where to start. You just want to do together, you have a question about, maybe you started it already, you want to double check any of those. Look at those, let me know any of them you want to do together, you have questions about, how do we start, anything like that.
How do we start? 2.
So I'll circle that one.
Calvin.
Any others? someone is playing music out of it. Earbud, AirPod, and it's way too loud.
It's not even.
No, from this one. Any other questions from this page? So like if you had a pop quiz, you could answer all the other questions. Taylor,
How did you do it?
9, Gabriella.
Yeah, it's good.
Just number two.
I said do number two.
You said do it then.
Nah, I said do it. Yeah, I said do it then.
All right, so I think this is a good list.
It's 32 and.
We don't
Just-
know each other that.
Yeah, exactly.
I'm so sorry, Aiden.
Thank you.
All right,
You
so we're gonna
forgive
start with
me?
number 2.
No.
So if we're trying to get M by itself, we have to get rid of the 4, we have to get rid of the 2. What do you think we're doing first? 2. Getting rid of it by doing what?
Subtraction.
Subtraction. So we're always doing the opposite. What we do to one side, we have to do to the other, so move it to the other side. And then we have to get rid of the 4. So we're going to multiply these.
Multiply.
Here you can use that word parentheses to multiplying to both sides. These words cancel, this leaving M. What would M equal? 32.
I don't remember this. I remember this. Evan, you remember this?
So
Yeah.
if I wanted to double check this, I could put 32 into M.
Oh yeah, I can tell you one.
You guys are really confident, Spanish. So 32 divided by 4 is 8. 8 plus 2 is 10 hours. Any questions on 2 before we go on to 3? Three, we're trying to get P by itself. What would we do first?
Subtract 30 plus 30.
Add 25 to both sides. Now, if this were a regular number, so like, let's say it was just 2P, what would I be doing to get rid of the 2? We would be dividing. However, this is a fraction. We don't, in math, like dividing by fractions, so we're gonna do this instead, and I'm gonna show you why. We're gonna take this number and we're gonna flip it, and we're gonna multiply that on both sides. This is called multiplying by the reciprocal. If you're taking the reciprocal, you're flipping it, and then you're multiplying it on both sides. Multiply here, so we get. It's gonna be a whole number. This over here is your multiplicative inverse, those cancel become 1. I did it differently than I. So there are different choices. You could have did what we just did. You could have multiplied by 3 and then divided by 2, which would make it 2 steps instead of 1. Or you could divide by the fraction. But again, we don't like dividing by the fraction. I'm going to show you why. Hold on. So if I were to divide by the fraction, still get the same answer. But usually when we divide by something, the number is smaller, but this one's bigger. So what this did was multiply by the reciprocal. Which is why you end up getting the same. So the choice is yours on how you do that. But as these questions get harder, it will be easier if you just take it, flip it, and multiply on both sides. A lot of okay. If I were to put this back in, it should also work.
Yeah, I know. You
So
know
that does
Omar,
work,
right?
that is your answer.
You know Omar? Omar. Yeah, NPC.
6, we're gonna wait and leave that for last.
It's not.
Let's go on to 7. Think about your simplifying. How would we start this? Jacob, got this. Okay, then. How would we start this? Also combine the -7 and the +4. So just like our simplifying, we're just now adding extra steps. So then what would we do next? Add 3 to both sides, correct? And then divide. So x equals. Right. If you were putting this in, so I'm gonna do this for this one and then I'm gonna kind of stop it with this. If I were to put this in, I'd have to put it in for all of the x's. So -4, -4. Someone read that equation off to me. I already forgot what it was.
Ooh, it's scary. So Evan. Evan. Evan.
So you did that right. Right, 9. What would be our first step? Multiply what? We will be multiplying now.
Stop.
Right, so now the process is the same. What's the next step? Find like terms, correct? And then.
Add 15.
Right? And then divide. We need to divide. I will say we check that in first period, it did work. But you can also check it in research. And help us with this one. Said we were gonna multiply first. You could not get rid of the 12 without getting rid of the 9, so we have to multiply first. And then. -6 minus 12 is -18. -18 divided by 9 is -15. That way. Right. So I want to leave 6 for last because there are 2 different ways to do it. One is dealing with the fraction. One is getting rid of the fraction. So we'll deal with the fractions first, and then I'll show you how to get rid of them if fractions are not your friends. Right, so dealing with the fraction, in order to add these two fractions together, the denominators have to be the same. So we have to think about a number that these two both go into, so we can change it. 6. So I would multiply this by 2 to get 6, which would do to one piece of the fraction, half of the other. Multiply this 2 by 3, same thing here. And then change them. The properties of equality don't apply to this because we're just changing the fractions so we can add them together. We're not doing something to both sides. It's different. Because these are now the same denominator, we can combine this into one big fraction. Combine your like terms. And then you have choices. You can either multiply by 6 and then divide by 7, or this is the same as 7 over 6x. So I could take this and flip it and multiply on both sides. So that x equals what? If I were to put 6 in, 2 times 6 is 12. 12 divided by 3 is 4. 6 over 2 is 3. 3 plus 4 is 7. That works. Right? If that way makes sense, do that way anytime you see something like that. If that way did not make sense, I'm going to show you a different way. You may not have space on this page. You can do it on the next page if you have space, or find somewhere else to put this. So we dealt with the fractions. This would be, you see the fractions, you start to freak out, you don't know what to do, you can do this. So instead of combining the two, I want to get rid of them completely, so I need to multiply both sides by something these both go into, so that 6 would still work. 6 doesn't have to be the answer here, it could be 12, 18, 24, keep going, but 6 is the lowest, so we use that. We're gonna multiply both sides by 6. But when you multiply 6 on this side, this is really 6 over 1. And you're only multiplying by it. Kind of like distributing, but only for the numerators. We still have the fractions for now, but we can simplify. We simplify these two, what would they become? Think about just dividing. 12 divided by 3. And 3x. Now we've gotten rid of the fractions completely. We can add our like terms. And then this one. You get the same thing either way. It's your preference on which one you've got it. Questions about solving multi-step equations? I know most of this should be for you, but there's something part in there. Okay. Take a second, stand, stretch your limbs. You've been sitting for a while, and then we'll move on to something else. So we're not gonna go through this entirely. I'm just gonna show you how this works, and if you want to use this, feel free to. This really only works for two-step equations where it looks like this. Okay. So in this process, you're given some equation slash something different. The steps represent how the equation came about. So pick a number that's your variable, multiply it by 7, add 5, the result. So this explains the equation, how to set it up. The answer part is like you solving it. You would start with the result of 26. You would put 5 to both sides. You would divide both sides by 7. You're looking for what is the answer. The check part is 2 things. It's doing what the answer just described. The result is 26, subtract 5, divide that by 7, the number would be 3. That's what I wrote. Then this part is putting 3 back in here because it doesn't. So if that helps you, use it. If that did not make sense, ignore everything I just said for this. Go on to the next one. The other piece of solving is the word problems. So there's a bunch of things going on when we do word problems. We're gonna skip number 1, come back to that, do number 2 first. The first thing with any word problem that you see after whatever, you should be circling, highlighting, underlining anything that you feel is important. So read this with me. To mail a first-class letter, the U.S. Postal Service charges a flat rate of 53 cents and 18 cents for each ounce. It costs $2.69 to mail your letter. How many ounces does your letter weigh? What do you feel is important there? Flat rate of 53 cents. That's 18 cents for each ounce. Yes, I'll make it. The cost $2.69. And then always the question, how many ounces does your letter weigh? Right, so that should always be your first step. Look and see what's important. The next step is we have to define a variable. If you're not sure about the variable, look at the question. The question is always going to help you define your variable because this tells you what you don't know. You can pick whatever variable you want. I would avoid O because you might use it for a 0. So X in this case is going to represent what? So
Ounces.
not these numbers because those are things you know.
Ounces.
Ounces. How many ounces? And we have to be very specific here. We can't just put ounces. We need to put what don't we know about that. So number of,
Ounces.
or you can put the weight. Right, so we found the important pieces of information. We defined our variable. Now we can start to set up our equation. We know it's going to cost us $2.69. Okay, this equals $2.69. Going back to translating, if we are looking for a total, what operation are we doing?
Adding.
Adding. So we're going to be adding these together. You can go ahead and put those numbers in, the order doesn't really matter. And I want to talk about a couple of the words in here that I'm going to picture. Flat rate is you're going to get charged that no matter what. So even if your letter doesn't weigh anything at all, you're still going to get charged 52 cents, which is how the postal service works. But then for every ounce, you're going to get charged each. So if you see words like for each or the word per, PER, those are going to go together. Whatever this is going to go with your variable. So your X is going to go with each. So now we have translated this word problem into an equation. Now we can solve it. How would we start doing? That is. And then divide. What was I? 12. But when we, just like when we define our variables, we were very specific. We would be specific with our labels as well, of what. If you just put a number on your quiz or your test, I'm gonna put 12 what? You need to put your labels. Questions on how we got that answer, solved it, set it up, anything like that? We're gonna go back and do number one. Number one is gonna be set up a little differently than how we just set this up. Okay, so one, it's talking about length with perimeter, so you need to have a little bit of knowledge about how to find perimeter. We'll go that in a second. But read this with me. The length of a rectangle is 3 inches more than the width. The perimeter is 30 inches. Find the dimensions. What's the that one important? More than, okay. But let's go with this entire piece. And what is this talking about? The length. So that part is important to know what it goes with. The perimeter is 30, that is also important. And then find the dimension. That means we need to find the length and the width of this. Okay, so first, what do you remember about perimeter of a rectangle? How would we find it with this area?
It's like
Yes, or that.
the lines. No too much.
You are on the right track. So perimeter is, you can add up all the sides, or you can use the formula. E equals 2L plus 2W. 3 times the length times 2 times plus 2 times the width. Okay. I did this opposite. So let's do this. We're gonna set up the equation for length, but first let's define our variables. This one would just be length and width. We don't have anything more than that for those. This one's a weird one because we are gonna end up getting 2 equations and then using that elsewhere. How would I say the length of a rectangle is 3 inches more than the width? I'm gonna say this first part, the length is the L equals.
33.
Say that again.
33 inches.
So this would be a number, operation, and a letter. Plus. Right, so now we have some equation for L. We know that this is our equation for P. We know our perimeter is 30. So I'm gonna put 30 in for P first. And then once you get the hang of this, you can skip that step and just go on to the next step. Because we have this L equation and we have L in our perimeter equation, we're gonna take this part and put it in for this L. So kind of like when we're evaluating, we put in a number into the equation, now we're putting in a whole equation into another equation. When you do this, you're gonna notice that one of the variables disappears. That should happen. If you still have 2 variables in this, something's wrong, something's wrong. But now we have a regular equation that we can solve. So what would be our first step?
Just 2 times.
The 2.
3.
Keep bringing down that 2W that was on the end. And then our next step, so add the two W's together. And then. Six. And divide. So what would then be equal? 6 what? Remember to put your labels. Because it said find the dimensions, so we have to find both the length and the width. If we have our width, how can we find the length? After, because we have an equation for length. You would still need to show this part, but then length would be 9. And if we put both of those numbers into our perimeter, we could get 30. So 2 times our length is 18, 2 times our width is 12, 18 plus 12 equals 38. Right? These are a little bit more complex than the one we just did. We're gonna do another one of those, and then I'll leave you to practice. Go to the very last page, but the back of that. Find the section that says perimeter of a rectangle. I'll let you guys choose. 9, 10, and 11 are all perimeter questions. Which one do you want to go over? And these are really the same. This is the one that's different. So 9, 10, or do you want to do 11? I heard a 9 in this. So 10 is 11.
10.
But we're only doing one. So we'll do 10 and then you guys try 11 or 9 or. Alright, so important information. Length of a rectangle is 5 inches more than 4 times its width. If the perimeter of the rectangle is 90 inches, find its dimensions. What's important here?
Five inches more.
Length 5 inches more than 4 times its width. What else? The perimeter is 90 inches, and we're looking for the dimensions. So let's set up our variables first. And then let's set up our length equation. Length of a rectangle is 5 inches more than 4 times its width. How would we set that up? Five plus 4W. Right, we know our perimeter equation from before is P equals to L for W. So we put 90 in. If once you get the hang of this, you want to just put 90 and then put this in for L, you can do that if you'd rather see both steps. So it's up to you. So then we're gonna put this in for L. And so on. Distribute this like we did before. 10 plus a W plus the 2W at the end. Combine like terms. Subtract 10 on both sides. What is W? 8 what? Then we have to find our length. How would we do that?
5 inches more than 4 times.
We're gonna put 8 back into W right here. Five plus 32, so length is 37. Once with any of these, the setup is really the same for every single problem. The last thing I want you to do for today, it may take you the rest of the class, it may not. Go back to these. I want you to try number 3. Number 3 has multiple parts. You can work together. You can use decimals. You can use your let me show you one thing on decimals before you do that. You can use decimals with your calculator, your notes with each other. Okay. I'm gonna say this. I'm gonna show you this on decimals, then you'll have time to work. Notice that blue car rental, it has your numbers here. Red car rental, it has your numbers here. A is just for blue car rental. B is just for red car rental. Because you're looking for total cost, you can just say equals total. You don't have to put a variable for that, just equals total. Because you'll be solving for that. On Desmos, let me show you this really quickly. You can check yourself on Desmos if you put the equation in completely. So this is a random one. It's actually one of the equations on one of your previous pages. You put this into Desmos. It's going to give you a line. Whatever that x value is would be the answer to this equation. So x equals 2. This is a good way to check yourself when you're at home doing practice problems. If you don't get this answer, something's wrong with your math, you can double check. Use Desmos, use your calculator, still show your work. If we have time to go over this class today, we will. If not, we'll do that on Thursday. You have this time to work through number 3, ask questions, use each other, use your calculator, use Desmos. Let me know if you need my help.